Welcome back to our series of revision, and today we want to look at solving a given quadratic equation. So the question we have is solve the given quadratic equation 4x squared plus 12x plus 9 is equals to 0. I've picked two methods here. The first method we are going to look at is the factorization method, and the second method will be the formula method. So in this particular case, we have the equation is given by 4x. We have 4x squared plus 12x plus 9 is equals to 0. So we want to solve this by the method of factorization. So in this particular case, this is a quadratic equation, and we are going to consider three things. One, we are going to consider the product of the common terms. We have to know the product of the common terms. We have to know the sum of these factors that we are going to get, and then the factors themselves. Now in this particular equation, the product value will be given by, if you are given a quadratic expression ax squared plus bx plus c, the product is given by the value of a multiplied by c, or a multiplied by c, and the sum is given by the coefficient of x, which is b. So we'll have to find the factors. In this particular case, our product is given by 9 multiplied by 4, which is equals to 36, and the sum is given by the coefficient of b, which is equals to 12. Therefore, we have to look for two numbers such that when you multiply the two numbers, you get 36, and when you add the two numbers, you get 12. Now, I want to take you to the factor tree method of getting these factors, but we are going to do it mentally. We know that 36 can be given by 6 multiplied by 6, or 36 can be given by 4 multiplied by 9, or 36 can be given by 12 multiplied by 3. And then we now have to test which of these will give a sum of 12. 6 plus 6 gives 12, 4 plus 9 gives 13, and 12 plus 3 gives 15. So in this particular case, our set of combination will be given by the first set, which is 6 multiplied by 6. So after getting that these are the workable factors, we rewrite the middle term. Now we get the expression 4x squared, and we rewrite the middle term using the two factors, which is 6. 4x squared plus 6x plus 6x plus 9 is equals to 0, like that. And then we now factorize by grouping. We take the first two values and the second two, we factorize them together. What is common here? We're going to get 2x multiplied by 2x plus 3 plus what is common between 6 and 9, 3 multiplied by 2x plus 3 to be equal to 0. After that, we're going to get what? 2x plus 3 is common. We can factor out that and write 2x plus 3 multiplied by 2x plus 3. 2x plus 3 to be equal to 0. So we can see that this is a product of two factors. It can be written as 2x plus 3 squared is equals to 0. Now, that equation is a perfect square. So to get the value of x, we get the square root on both sides. We take this expression now, 2x plus 3 squared is equals to 0. Get the square root on both sides. When you get the square root on both sides, you're going to have 2x plus 3 is equals to the positive or the negative square root of 0. The negative or the positive square root of 0. Now, the square root of 0 is equals to 0, so it will remain 0 on the right hand side, and then we are going to write this as now 2x plus 3 is equals to 0. After doing that, we subtract 3 from both sides. We'll get 2x is equals to negative 3. And to get the value of x, you'll get 2x is equals to negative 3. Therefore, divide both sides by 2. And here by 2, you'll get x is equals to negative 1.5. Negative 1.5. So that will be the value of x using the factorization method to solve that equation. The second method that we want to look at is the formula method. We want to solve the same equation using the formula method. You don't need to cram the formula method. This can be easily obtained from the log tables, and when you extract the formula, it is important that proper substitution and evaluation of the values is done. So our equation was given by 4x squared plus 12x plus 9 is equals to 0. So from the tables, the value of x, using the formula method, the value of x is given by negative b plus or minus the square root of b squared minus 4ac, all this over or divided by 2a. So from our equation, a is equals to 4, b is equals to 12, and c is equals to 9. Therefore, we go to the equation and substitute for these particular values. Therefore, x will be the same as negative b, negative 12, plus or minus the square root of b squared, 12 squared will be 144 minus 4 multiplied by 4 multiplied by 9. All this over 2 multiplied by 4, which is 8. So we're going to have the solution as, or the value of this. When we continue, we're going to have x is equals to negative 12 plus or minus the square root of 144 minus 16 times 9 will give us 144 over 8. So the value of the discriminant here can be seen to be equal to 0. b squared minus 4ac is equals to 0. Now attesting to the fact that this is perfect square. So we are going to have now x will be equal to negative 12 plus or minus 0 over 8. So when you simplify this, you're going to get x is equals to negative 1.5. Now we are still getting the same solution as what we obtained on top here using factorization method. In the next question, we are going to look at a question that is going to jog our minds. And we are given a quadratic equation, and we are told to express, or given a quadratic equation, or given that 25x squared minus 20x plus k is a perfect square, you are now asked to find the value of k, or to complete that equation into a perfect square. So we have the question with us on the board. told that given that 25x squared minus 20x plus k is a perfect square, find the value of k. Find the value of k. So this is more or less completing this equation into, or making it to become a perfect square. We have 25x squared minus 20x plus k, and we want to make it a perfect square. The easiest way to make this a perfect square, we need to recall that the third term in a perfect square is given by the middle term squared, over 4 multiplied by the first term. Again, the first term is given by a, which is equals to 25. The middle term is given by b, which is equals to negative 20. And the third term is given by c, which is equals to k in this particular case. So, which is unknown to us. Let me not use two letters which are not unknown to us. Let us just say the value of c, though c is given as k. Therefore, when we come to substitute in this formula, we are going to get the value of k, which is the third term, is equals to negative 20 multiplied by negative 20 over 4 multiplied by 25. So we can simplify this. You cancel out with common factors. By 5 you'll get 5. By 5 you'll get negative 4. By 5 you'll get 1. By 5 you'll get negative 4. By 4 you get 1. By 4 you get negative 1. So you'll get negative 1 multiplied by negative 4, which is equals to 4. Therefore, we can now conclude and say, therefore, the value of k is equals to 4. So when k is added here, in this particular quadratic expression, it will become a perfect square. In the second question, you're told the expression b, the expression bx squared minus 56x plus 16 is a perfect square where d is a constant. Find the value of d. Find the value of d. Again, we're going to use the first method to get the first term d, which is not known to us. So as we have seen on top here, the third term is given by the middle term squared over 4 times the first term. Rearranging this particular expression, then the first term will be given by the middle term squared over 4 times the third term. So the first term is given by the middle term squared over 4 times the first term over the middle term squared over 4 times the third term. So d squared, or d will be given by the value of d now will be given by negative 56 times negative 56 over 4 multiplied by 16. 4 multiplied by 16. So when we simplify this, we are going to get what value? The common factor between 56 and 16, negative 56 or 16, 8 can easily get into 16 twice, and 8 will get into negative 56, negative 7 or 7 times. So again, we can still divide negative 56 by 2. By 2 we get 1, by 2 we get negative 28. And then negative 28 can be divided by 4. By 4 we get 1, and by 4 we get negative 7. Therefore, the value of d now will be equal to negative 7 times negative 7, which is equals to positive 49. Therefore, in this particular case, therefore, we conclude and say that d is equals to 49. So when 49 is added, when 49 is made the coefficient of x squared, then that particular expression becomes a perfect square. It becomes a perfect square. We still want to look at another question related to that concept. This question is on the board. The expression told that the expression 9x squared plus 12x plus 1 plus c is, where c is a constant, is a perfect square. Find the value of c. Find the value of c. So this is where we have the question that we want to look at. The expression 9x squared plus 12x plus 1 plus c, where c is a constant, is a perfect square. Find the value of c. Find the value of c. This is our expression now. 9x squared plus 12x plus 1 plus c is a perfect square. So what is the value of c given by? In this particular case, the third term is given by, if you look at the expression carefully, the third term now is given by 1 plus c. 1 plus c. And to get the third term, as we have said on top, the third term will be given by the middle term squared over 4 times the first term. So in this particular case, our first term is 9, the coefficient of x squared. Our middle term is equals to 12, and our third term, which is comprised by 1 plus c, is not known to us. That is what we want to get. So when we substitute this, we are going to get what? We are going to get the third term, 1 plus c, will be equal to the middle term squared, that is 12 times 12, over 4 multiplied by the first term, which is 9. Again, we can simplify this easily. By 4 you get 1, by 4 you get 3, by 3 you get 1, by 3 you get 3, by 3 you get 1, by 3 you get 4 by cancellation method. So 1 plus c is equals to 4. Therefore, in this particular case, we are saying 1 plus c is equals to 4. C alone is equals to 4 minus 1, which is equals to 3. Therefore, you come and conclude and say that, therefore, C is equals to 3. C is equals to 3. So with that particular expression, when C is equals to 3, that particular expression will become a perfect square. The next question, we are going to look at a simple question on indices and bases, and just to go out a bit, you're given this particular question to solve. I've just gone out of the quadratics a bit. We'll come back to quadratics. So what if you're given a question of this nature to solve? You're told to solve this particular equation. Solve for x. In the equation, 49 raised to power x plus 1 plus 7 raised to power 2x is equals to 350. Of course, at most here you'll earn 3 3 marks. So to solve this type of an equation, we can see that 49 can be expressed in terms of a base of 7 raised to a certain index, since we have 7 here. So 49 can be written as 7 squared. So when we write 49 as 7 squared and we replace 49 with 7 squared where we have 49, our new equation will be written as 7 raised to power 2, or 7 squared into brackets x plus 1 plus 7 raised to power 2x is equals to 350. When you open the powers in the bracket on top of the index, we're going to get 7. When we open the powers now, we are going to get 7 raised to power 2x plus 2 plus 7 raised to power 2x is equals to 350. We need to remember that when the bases are the same, we normally add the powers. When we're multiplying indices with the same bases or powers are normally added. This is to say a raised to power m multiplied by a raised to power n is the same as a raised to power m plus n. Therefore, in this particular expression, we can write it as 7 raised to power 2x multiplied by 7 raised to power 2 plus 7 raised to power 2x is equals to 350. And then we can factor out what is common. 7 raised to power 2x, factor out that and write it as 7 raised to power 2x into brackets 7 squared plus 1 is equals to 350. After doing that, 7 squared plus 1 will be given by 50. And then we divide both sides by 50. We are going to have 7 raised to power 2x is equals to 350 over 50. So we divide here by 50, we divide here by 50, and here by 50. I don't need to write that. So 7 raised to power 2x is equals to 350 divided by 50, which is 7 raised to power 1. At this particular point now, we compare the indices because the bases are the same. So this implies that 2x will be equal to 1. X alone, we divide both sides by 2. X will be equal to a half. And that is your answer for that particular question. we can continue, go back to the quadratic equations, and it would be now wise to look at another most important area where you can be tested on. And in this particular case, the examiner can test your knowledge on whether you can be able to solve a given quadratic equation by the method of completing squares. So that is what I want us to look at right now. What if you're given an equation, you're given this particular equation, but f solve the equation 2x squared plus 4x minus 3 is equals to 0 by the method of completing squares. The marks to be awarded here would be 3 marks. Solve the given quadratic equation 2x squared plus 4x minus 3 is equals to 0 by the method of completing squares. What we need to do, we rewrite the equation. It's already given to us. We're going to get 2x plus 4x minus 3 is equals to 0. So we are going to add negative 3, or to add positive 3 on both sides. Because this is a negative 3, add positive 3 on both sides, so that we have a third term which is not known to us. So when we add positive 3 on both sides, we're going to have 2x squared plus 4x is equals to positive 3. Now we need to introduce a third term to us, or we can as well make the coefficient of x be equal to 1 before we introduce the third term, and we are going to have x squared by dividing both sides, or everything by 2, x squared plus 2x is equals to 1.5 or 3 over 2. Therefore, we now introduce a third term so that we can make this a perfect square. We have to introduce a third term, and we shall write this as now x squared plus 2x plus a third term that we do not know to be equal to 1.5 plus the third term, so that we can balance our equation. We have already seen that the third term is given by the middle term squared over 4 times the first term. Or, to complete this perfect square when the coefficient of x squared is 1, this third term will be given by a half multiplied by the middle term. A half multiplied by 2. So when you multiply a half by 2, you're going to get 1. A half times 2 gives you 1. So this term here will be equal to 1. Therefore, we are going to have it as x squared plus 2x plus 1 is equals to 1.5 plus 1. So we've added 1 on both sides to balance our equation. At this particular point, we are going to factorize this expression, which now is a perfect square, and the factors of x squared plus 2x plus 1 will be given by x plus 1 multiplied by x plus 1 to be equal to 1.5 plus 1, which will give you 2.5. Therefore, we now are going to have what? X plus 1, all this squared, x plus 1 squared is equals to 2.5. Since we are solving this, we get the square root on both sides. X plus 1 will be equal to the positive or the negative square root of 2.5. X plus 1 is equal to the positive or the negative square root of 2.5. This one can easily be obtained from the calculator. X plus 1 will be equal to the positive or the negative value of the square root of 2.5 is equals to 1.581 correct to 4 significant figures. 1.581 correct to 4 significant figures. X alone will be given by either 1.581 minus 1. We subtract 1 from both sides. So this is positive 1.581 minus 1, or x will be given by negative 1.581 minus 1. So this gives you 0.581 1, and this other value will give you negative 2.581 or negative 2.581. Therefore, the set of values for our equation, will be given by x is equals to 0.581 or negative 2.581. Negative 2.581. With those few questions on quadratic formula, factorization, and the method of completing squares, I'm going to end today's video, and let us meet in the next lesson. Kindly subscribe, like, and share. Thank you for listening.